All right, today we're going to talk about section 8.1, accumulation and net change. All right, so we're going to start off with reviewing, going back to linear motion. So when we did linear motion before, we said that the derivative of the distance traveled s was v. We also said that dv dt was acceleration, okay? So if we took the derivative, if we took the integral of both of these, we would find that s is equal to dt, v is equal to dt, okay? So basically, this is what we're going to use. These are what we're going to look at today. So let's see, we'll go right off with example number 1. Example number 1 says figure 8.1 shows the velocity, and the velocity is, gives us as ds dt is equal to v, and this is t squared minus 8 over t plus 1 squared. It actually gives us the graph. The graph looks like this. Okay? And it says, describe the motion. So we're going to describe the motion. So what's happening here? We have, this is the velocity. This is the velocity here, okay? So the velocity starts from a negative point. So in other words, we're going to have a negative velocity. What does a negative velocity mean? Negative velocity means that if we consider this part to be the positive velocity, we're going in the negative direction. So we're going in a negative direction this way, and then what happens? And then we go to 0. Velocity of 0 means it stops, and then it goes positive. So we're going to go this way and this way. Okay? And that's basically where we are, okay? Let's see what the solution says. Okay, we're going to start. Oh, sorry, the velocity is -8. So this here was -8. 1.25 seconds. Okay, and this over here, I believe, was... Let's see where we are. 24.8. So this is 24.8 over here. Okay. And that was at 5 seconds. 5 seconds. 5 seconds right here. Okay. All right. So basically that's what happened. So we're going from -8. We're going 8 in this direction. Then go back here. And then we go over here. And then we're at 24.8 at the 5 second mark here. Okay. Example number 2. Supposing initial position was 9. What is the particle's position at t equals 1 and t equals 5? Okay. So in example number 2, it has the same thing, but it tells us that s naught, the initial position, was equal to 9. Okay? So, since we have this, we have s is basically v dt. We know that. So we're going to have what? We're going to go t squared minus 8t plus 1 squared dt, correct? Right? So if you look at it, this is way back when the very first example that we started with, when we started to talk about integration, was area under the curve, right? Area under the curve. So area under the curve of the velocity was the distance traveled, correct? Same thing here, okay? All right? So this is going to be what? So we're going from 0 to where? 1 second? 0 to 1 second. So we get 0 to 1. T squared minus 8t plus 1 squared dt. t, so we get what? This is going to be 1/3 t cubed. Then over here I'm going to have plus 8t plus 1. And I'm going to evaluate this from 0 to 1 as such. So I have 1. Put 1 in here, I get 4, 8/2. Then subtract from that the 0 part, and the 0, this becomes 0. If I get 0 here, I get 8. Right? So what do I have? I have 4 1/3 minus 8, which is what? Minus 3 2/3, correct? So in other words, I went from 9, but I started from 9. Right? I started from 9 right here. I ended up going this way, this amount. So I traveled that amount. So I went to the left 3 2/3. Okay? And, whoops, something's wrong here. What do we get wrong? 4, 8, no, I'm good. I'm good. Oh, we're good. Okay, yeah. So this is what? So if I take 3 1/2 off, so this is what? Negative 11/3. And we have 3/27, so 16. This is where we're going to end up being. Okay? Because we started at 9, all right? So basically, what this means is that we end up going with an equation that says what? The equation is going to actually look like S is equal to VT plus S0, correct? Because this is where we actually started from, and this is the actual change itself. Okay? And then B is T is equal to 5 instead of 1, so same thing here, except for this becomes 5. So we're going to go from 5 over here. So when we get 5, we get what? T cubed is 125 plus 5 over here. When I put 5 down here, I get 8/6. 8/6. Right? And that's still going to stay the same. So I get 125/3 plus 4/3 minus 8. So I get 129/3, 129/3, which is 43, minus 8 is going to be 35. So this is going to be 35. So I started from 9, added 35, so I end up at 44. Okay, so we're going to end up at 44. All right, let's take example number 3. Calculating total distance traveled. Total distance traveled meaning what? Meaning that now we are going to do the total distance traveled. So this guy here, which actually was negative and canceled out this amount, some of this amount here, now I have to flip this over and this becomes positive also. So in other words, we're going to go like that, right? So if you do that, what changes here? So basically now, the easiest way is just go ahead and int it using this, right? Use a int. We can do a int. Or we could go what? Negative from 0 to 1.25, because I know this part is negative, so I'm going to put the negative here to flip it over to count it as positive now, right? So I'm going to have VT dt plus 1.25 to 5 VT dt, correct? All right, so I can go ahead and do that. So that's how you would do example number 3. All right? So off the page, let's go to example number 4. In example number 4, it says modeling the effects of acceleration. So let's go ahead and do that. example number 4. It tells us that a car moving with an initial velocity of 5 accelerates at the rate of that per second for 8 seconds. So my initial velocity is 5, and a sub t is 2.4 t. Okay, and for 8 seconds. A, how fast is the car going when the 8 seconds are up? So for during the 8 seconds, what was the change, right? So I'm going to go like that, 0 to 8, right? dt. So I'm going to go 0 to 8, 2.4 t dt, which is going to be what? 1.2 t squared, 8 to 0, 1.2 times 64, I guess, right? And if we do that, we're going to get 76.8. 76.8. Okay, so this was the net change. From 0 to 8, this is how much the velocity gained. Where do we start from? We started from 5. So the final velocity is going to be, you have to add the 5, 81.8. Okay? So that's that. And then we go B. How far did the car travel during this time? So how far did it travel during this time? So now we're going to look at S, right? So in order to do S, we're going to have to find V sub t, right? We have to find a V of t, right? A V of t. So V of t is what? So V of t, we go back here. What was the equation for your V of t? V of t is what? V t was equal to a t dt, right? Right? So this is going to be what? 2.4 t dt, and from 0 to t. Okay. Right? So what's wrong with this? Okay, I cannot have the same variables here that's up here, right? So instead of using t's, we're just going to use a dummy variable. We'll do, I think the book used u, so we'll do u. Okay? So we're going to have, this is going to be 1.2 u squared, right? From 0 to t, so it's going to be 1.2 t squared, right? So my s is going to be basically what? S is going to be 1.2 t squared dt, right? But I want to know from where to where? From 0 to 8, right? From 0 to 8? 0 to 8, right? But if we also had the initial velocity, right? So the initial velocity, so Vt itself was going to be 1.2 t squared plus 5 here, right? So I have to put the 5 in there. dt. So now I'm going to get what? 0.4 t cubed plus 5t, and I'm going to go from 8 to 0, right? And if I do this, put this in my calculator, I get what? I get 244.8. 244.8. Okay? And we'll do that. Let's do one more. Let's do example number 5. Example number 5, there's a consumption over time. And we're going to talk about potatoes consumed in a certain country. So it has, from 1970 to 1980, the rate of potato consumption in a particular country was 1.2 plus 1.1 t. So consumption of the potatoes looked like that. In millions of bushels. Okay, t being the year since the beginning of 1970. How many bushels were consumed during the beginning of 1972 to the end of 1973. So basically what? We're going to go from year 2 to 4, and it's going to be CTDT. So it's going to be 2 to 4, 2.2 plus 1.1 T dt. So it's going to be what? 2.2 T. And this was what? This was 1.1 T over natural log of 1.1. I'm going to evaluate that from 4 to 2. Okay? And looks like the book just goes ahead and nymphs this. Anyway, we get 7.066. Okay? So that's simple 5, and we'll go ahead and call it a day here.